Assalamu alaikum. Today, inshallah, we will explain electrode potential. First, we should know about half cells. If a metal electrode or rod immersed in solution of its ions, what will happen? The tiny atoms of the metal, either it is zinc or any other atom, the tiny atoms of the metal, it tend to lose electrons to form ions that migrate in solution, leaving the electrons lost at the surface of the electrode or rod. This surface now is negatively charged. That's why it will attract the positively charged ions from the solution to accumulate near its surface. Now we have two layers, negative and positive one, that's very near together. Accumulation or build-up of these charges will form what we call electrical double layer. This electrical double layer, it means that a voltage or potential can be produced by this half cell. Okay, let's take zinc as an example here. Zinc system, zinc ions as a half cell, it can generate or produce a potential, and this potential is called the electrode potential. If these conditions are standard conditions used, then the potential will be called standard electrode potential. Okay, what are the conditions used to give a standard electrode potential? The symbol of standard electrode potential is E standard. What are the conditions that should be used to make or create a voltage of standard electrode potential? First, the ionic concentration of the solution, it should equal 1 mole per decimeter cube. The pressure should equal 1 atmospheric pressure. And temperature, it should be 25 degrees Celsius or 298 Kelvin. By using the standard conditions, then the potential or voltage produced, it is called standard electrode potential. And it is given the symbol, as we said, E node. Okay, how can I measure this voltage or potential? Generally, we can use a voltmeter, but here in a half cell, we cannot directly connect a voltmeter to the half cell and measure the voltage. We should connect our half cell first to another half cell that will act as a reference, and then the difference in voltage will be measured by the voltmeter. We usually use hydrogen or standard hydrogen electrode as the other half cell connected to be used as a reference in the measure of any standard electrode potential. What is the standard hydrogen electrode composed of? We should know the drawing, labeling, all about the standard hydrogen electrode. It is made of a platinum wire ending with platinum plaque. Platinum plaque is finely divided platinum particles, very finely divided, at which the hydrogen gas will be absorbed to be in close contact with hydrogen ions in solution. This is surrounded by a glass tube ending with a bell-shaped part with a small hole to allow the hydrogen gas bubbles to go out. At the top of the tube, we have the source of hydrogen gas to be introduced from here, okay? And this is all the hydrogen electrode. Standard, it means, once again, that the concentration of hydrogen ions here is 1 mole per decimeter cube. The pressure of the gas introduced, 1 atmospheric pressure, and the temperature at which we are carrying this potential or electrode cell is 25 degrees Celsius. Okay, after connecting, how we will connect? Simply connecting two half cells now, the hydrogen electrode half cell and the metal electrode half cell, either it is zinc or any other metal. We will connect using wires, voltmeter, and the solution to complete our circuit to become a complete electrical circuit. We should connect the other part, which is ions here. The two ions of hydrogen and the metal, it should be connected by what we call salt bridge. Salt bridge is usually we use like a filter paper soaked in a solution of one of the most reactive metals, potassium nitrate. Now our circuit is complete. Voltage will go, or electrons will go through wires, and it can be measured by the voltmeter. Let's see what will happen in this electrochemical cell. Electrochemical cell composed of two half cells. Let's see what will happen when we will connect a hydrogen electrode to any other half cell to measure the voltage. We have a half cell of zinc. As we said, zinc system. It is a redox system. Two species of the same element with different oxidation number. Now we have a redox system. What will happen? We have two reactions, oxidation and reduction, in which the zinc particles or atoms in the rod, it can be oxidized by losing two electrons and forming the zinc ions. At the same time, we have a reduction reaction in which zinc ions in solution can gain two electrons to reform the particles or atoms of zinc. Zinc as a reactive metal, it tends to shift the redox equilibrium towards the right. It's reactive. It needs always to be in its ionic state. Reactive metal tends to be in its ionic state. So we will see that equilibrium in this system is generally shifted towards the right, towards the formation of ions or the oxidation reaction. Okay, these two electrons, where will it go? It is connected, as we said before, by wires to the other half cell, which is hydrogen half cell. The two electrons will be gained by the ions of hydrogen. Two ions of hydrogens gain two electrons to form hydrogen gas in a reduction reaction. We have oxidation reaction here? Yes, we have. It's a redox system once again. Two species of the same element with different oxidation state. Hydrogen, it has oxidation state of 0, oxidation number 0, and oxidation number of ions here plus 1. So we have a redox system as usual in any half cell with oxidation and reduction. But as we said, it is connected to zinc, which will act as a releasing half cell of two electrons that will be gained by the hydrogen ions. In this case, we will find that the equilibrium here in this system is generally shifted towards the left, a reduction reaction. Okay? We can tell here that the redox system, that's equilibrium, in which the equilibrium is shifted towards the reduction, it will act as a positive pole. It's always receiving electrons from the other half cell. The redox system, in which the equilibrium is shifted towards oxidation, it will act as a negative pole. It's always releasing electrons to the other half cell by which it is connected. Okay, let's see another example here in case of unreactive metals like copper. If we need to measure the potential of a redox system of copper, once again we will connect it with the standard hydrogen electrode. Let's see what will happen. In the half cell of copper, we have copper metal oxidized to give copper ions and two electrons. These ions in the solution can regain electrons to be reduced to form the copper metal. Once again, this is a redox system. Equilibrium is established. But as unreactive, copper is unreactive, so we will find that the tendency of the system is to be shifted towards the formation of the metal, not the reactive ion. In this redox system of unreactive metal, the equilibrium will be always shifted towards the reduction, the formation of the metal. It's more stable like that. So, if it is shifted towards reduction, it means it is, yes, a positive pole. It's always acting as receiving electrons from the other half cell by which it is connected. So when I will connect the copper system with the standard hydrogen electrode, here, standard hydrogen electrode will act to give electrons to the copper system. How will it give electron? The equilibrium will be shifted towards, yes, oxidation, the release of electrons. In this case, hydrogen will form hydrogen ions, hydrogen gas will form hydrogen ions, and the release of 2 electrons. These 2 electrons will be transferred by wires or move through wires to the other half cell of copper to be gained by copper ions and form copper metal. In this case, the standard hydrogen electrode will act as, yes, a negative pole this time. It's the source of electrons. It will always release electron to the unreactive metal of copper. So, here we should just make a summary of that. In case of reactive metals connected with hydrogen, standard hydrogen electrode will act as a positive pole, receiving electrons. In case of unreactive metals like copper or silver, it's less reactive than hydrogen, so the standard hydrogen electrode will act as a negative pole. It's a source of electrons that will be received by the other half